Good afternoon, ma'am. I am Anjali Shukla from B2 batch, roll number 107, going to present IA 11 research paper named Supporting Uncertain Predicts in DBMS using Approximate String Matching and Probabilistic Database by author Amol S. Dwivedi and Ravindra Keskar. Here is a rough summary before starting. Current relational database systems are deterministic in nature and lack the support for the approximate matching. In this paper, the authors propose a system to support approximate matching in the DBMS field. This paper introduces a approximately equal to operator for approximate matching and devises a normal formula to calculate the similarity scores. We get result ranked according to their closeness to the queried literals. The paper includes results of operation on performed on IMDb movie database and the European football database. Two variations of the operators, that is approximately equal to plus and approximately equal to minus, are also discussed. Let us start with the presentation then. Pattern matching in deterministic database. Traditionally, we use like operators and the pattern is described using the special characters percentage and underscore. Also, we use comparison operators like greater than equal to and not equal to bracket, as well as the like operators too, where clause is used for the condition. Here, a comprehensive knowledge of a database is required, or we might get an empty result set. Below, we can see an example for like operator in a traditional database. Now, what is the need of uncertain matches? The empty result set might also be caused due to a single misspelled word or a typing error. Problems may arise due to the homophonic nature of the word. For example, Christopher starting with C or a Christopher starting with a K. Instead of returning an empty result set, it will be better to return the result set ranked according to the degree of the similarity. From the approximate results that the user would get, she would come to know about the actual values in the database. She may requery with the exact keywords that she intended. Now, let us understand the example of the uncertain predicts. Let us assume that there exists an uncertain predict operator denoted as approximately equal to, which is used for approximate matching. The result of the given query could be a relational annotated with the percentage of a matching. This matching scores can be treated as the probability scores or the confidence scores for the respective tuples and can be stored with the tuple. The result set is ranked according to the derived probability, indicating the most credible, that is the highest probability answer first. Below is an example for uncertain predict for approximate matching and the table for expected result of the given query example. Moving on to the literature survey. Let us first talk about the uncertainties and the probabilistic databases. Nowadays, many applications have to deal with an uncertain data such as an sensor network, object recognition, moving object monitoring, etc. The use of a null is proposed to handle the uncertainty in the traditional databases. This may result in a loss of information. Probabilistic databases stores uncertainty in the terms of a probability for that uncertain tuple or attribute. For an example, let us consider an institute has installed an automated system for maintaining and students' attendance. Below is an example for a probabilistic database. Moving on to the approximate string matching, that is ASM. ASM aims to find the closest match for a query string. The uncommon part between the two strings is considered as an error between them. The approximate string match is generally measured in the terms of distance. The distance matrices are classified into three major categories, namely edit-based, heuristic-based, and Q-gram-based or N-grams. Moving on to the methodology. The basic model of the proposed system is follows like pre-processing. These certain predicts are applied and we obtain the filter results. Distance calculation. This model calculates the distance between the queried literal and each of the field values in the corresponding column to get the distance array. Next is a distance normalization. Distance array is normalized in the range 0, 1. Next comes the probability calculation. This model combines the probabilities obtained from the uncertain predicts to calculate the final probability of the filtered tuple, and finally we get the probabilistic database as an output. Here we can see a block diagram of the proposed system for the same. Now the naive solution to calculate the distance between two strings is as follows. Q-gram distance needs O absolute power of omega raised to Q storage. To avoid such high space complexity, we use auxiliary table to calculate the Q-gram distance between the two strings, that is S and T in RDBMS. Then the auxiliary tables are created and deleted later. Below is an example for the naive solution using auxiliary table. Now, what is the proposed system to calculate the distance between two strings mentioned in this research paper? First is the local Q-gram. The length of a larger string y is divided into the set of a substrings yi's, where the length of each substring is equal to the length of a smaller length string x. Lx and Ly are the length of the strings x and y respectively. N equals to Ly minus Lx plus 1, which will be the number of a possible substrings, that is yi's of the length Lx and of a string y. Next is a global Q-gram distance, that the first string may be contained anywhere in the second string. Hence, to minimize the distance between two strings, minimum of a local Q-gram distance is considered as min d1, d2 till the dn. Higher the length distance amongst the matched strings, higher will be the penalty. A ratio that measures the amount of the cumulative dissimilarity between the two strings measured relatively against the maximum distance is added. For the data types like numeric or a date, a simple absolute difference of the value will be the distance between them. Here is a table for the result of the proposed formula on the some sample strings, and auxiliary table storing local Q-gram distance, and SQL query for calculating the global Q-gram distance. Now let's moving on to the complexity analysis. In naive solution, the time complexity is O, absolute power of x into absolute power of y, and the memory requirement is O, absolute power of q in bracket y comma q. In proposed solution, time complexity to O is absolute power of x squared into y, absolute power of y. But memory requirement will reduce to O till the absolute power of q of x comma q. This overheads with the improved accuracy of the system. Now, normalization of a distance array. All distance array may differ in the range of the following values. For the uniformity distance array are normalized in the range 0, 1. Below is the formula for the calculating the same. Moving on to the final probability calculation. The final probability will be obtained by AND, OR, and conditional operation, etc. They are solved in accordance with their precedence that can be overwritten by parenthesis. Precedence of is the higher than OR. Now, the results and discussions of the research paper says that as a part of our experimentation, the authors compared the performance of the naive approach with the proposed solution. They also compared the results of the proposed global Q-gram distance with the classic edit based resistance. We analyzed the effect of the value of Q on accuracy. They have also presented the result of the additionally proposed operators, that is approximately equal to plus and approximately equals to minus dot h, the proposed solution. Below is an example for sample query on the IMDb database. Now let us talk about the effect of the value of Q. The experiment shows that a small value of Q is more likely to give a better result. The optimal value of Q equals to log of absolute power of omega into absolute power of s, where omega is the finite set of the alphabets. Therefore, the value of a Q equals to 2 or 3 is a more favorable. The results are not reliable for the Q equals to 1. It is obvious because no Q-gram overlapping happens and no ordering of the characters is checked when the Q-gram size is 1. By providing support for uncertain predicts in this work, we are in a way trying to achieve the same feature in traditional databases as information retrieval, that is IA systems used to retrieve web pages from the search engine. Now, the conclusion of this research paper and the future work that they have mentioned is a database management system to support the uncertain predicts is proposed through the similarity between the values of string is measured in the terms of a modified Q-gram distance, that is local Q-gram distance and a global Q-gram distance. A novel formula to calculate this distance between the string is proposed and they explained in detail. A set of a sample query indicate how this could be a beneficial as an extension to additional variants of the uncertain predict which add to the practicability of the system are introduced. The proposed global Q-gram distance may find its application in other fields like record linkage, data deduplication, DNA sequence alignment, etc. This is the implementation strategy that have been used, and this is the bibliography. Thank you.